I was bored last night when I stumbled across this geometry problem. It looks aesthetically pleasing to me, so I've decided to give this one a try. There are two circles that are tangent to each other, and both are tangent to a small square. All of these shapes lie on the same horizontal plane. If the radius of the circles is 5 units, then what is the area of the small square? Without further delay, let's jump right into it. Let's name the vertices of the square as points A, B, C, and D, and then let M be the midpoint of the side CD of the square. The left circle is tangent to the horizontal surface at this point, and from here, draw the diameter of the circle. Label the endpoints as point E and point F. Now, from point F, let's draw a line towards point A. And then from point A, draw another line towards point M. Here is the critical question here. Do you think this entire line FM is a straight line? We don't know for certain yet. Sure, in my diagram it looks like a straight line as it was made using a software, but that may not be the case if you try to draw this on a paper using your hands. Therefore, we're going to have to prove it. It is a known fact that squares have right angle corners, so we can say angle ADM is a right angle. Next, let O be the center of the left circle. According to the tangent of a circle theorem, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Since circle O is tangent to the horizontal line at point E, we find that angle OED is a right angle. Next, let's zoom in on right triangle ADM and compare it to right triangle FEM. Notice how the two triangles share the same angle, which is angle M. The two triangles clearly have two angles of same measures, which tells us their third angles, angle F and angle A, must also be congruent. And since angles EFA and DAM have equal measures, then it's safe to say that line FM is a straight line. And that line passes through point A. You'll find out shortly the importance of line FM being a straight line. For the meantime, let's keep this going. From point A, draw the line towards point E. Now, Thales' theorem states that if a triangle is inscribed in a circle with one side acting as the circle's diameter, then the angle opposite that diameter is always a 90-degree right angle. This theorem is telling us that angle FEA is a right angle, because the side FE of triangle FEA is also the diameter of the circle. And because we are now sure that FM is a straight line, then the measure of angle EAM must be 90 degrees as well. Because, the sum of angles in a straight line must be 180 degrees. Recall that the radius of this circle is 5 units. If you look closely, you'll see that the line segment EM has the same length of 5 units. Moving forward, let x be the side measures of the square. Since M is the midpoint of side CD, then the length of segment DM must be half of x. Using segment subtraction, the length of segment DE is equal to 5 minus x over 2. For the final step, we will use the geometric mean altitude theorem. According to this theorem, the square of the length of the altitude to the hypotenuse is equal to the product of the segments of hypotenuse. Applying this to our problem, the square of x is equal to 5 minus x over 2 times x over 2. I'm going to need to remove the diagram for now to give myself some room to solve. Multiply x over 2 to both terms in the binomial. That's 5x over 2 minus x squared over 4. Multiply both sides by 4 to remove the denominator. This is 4x squared. 4 divided by 2 is 2 times 5, so 10x. and then 4 over 4 is 1, so just write minus x squared. Add x squared to both sides. And the equation becomes 5x squared is equal to 10x. Divide both sides by 5x, and we should get x equals 2. This means the sides of the square are 2 units long. The area of a square is side squared. Substitute the side lengths of 2, and 2 squared is 4. The area of the square is 4 square units. Thanks for watching.